Starting with gravity. So if objects x and y exert a gravitational force F on each other, the mass of one is doubled and the distance is doubled, what is the new gravitational force? So I've doubled one of my masses, doubled one mass and doubled the distance, but r gets squared, so really that's a factor of 4 on bottom and 2 on top. These ones no coefficient, so that's like nothing happening. So then that is just 1/2 smaller, so if the old force is F, that is 1/2 F for B. Two objects are 9 centimeters apart. If they move to only 3 centimeters apart, how does the force change? Well, first of all, let's just think. If they're 9 centimeters apart going to 3, and when I get closer together, that's less distance, so that's going to be a bigger force, stronger force when it's closer together. So we can cross off the decrease. We know it's going to be increasing. It's going from 9 centimeters to 3. That's 1/3 of the distance. Now, it's tempting to be like, oh, 1/3. But that's 1/3 the distance. So if we were to plug in what happens to your force, that'd be 1/1/9, which is actually times 9. So it's increasing by a factor of 9. These 3 planets are identical. They have a giant moon on these 2 and a lightweight artificial satellite. Which one has the greatest, strongest gravitational? I meant this to be force, so the greatest force between them. Well, the force equation is g/m/r². The first mass would be like the mass of the planet, which is the same for all of them. The second mass would be like the mass of the moon, so this is heavy. This one's lightweight. So if I want a big force, I want big masses. So I'm going to cross off the small mass one. And then the difference between A and C is the distance. Again, if we want a big force, we want a small distance. So A, because it has a big mass and it's small distance. So A, because it's heavy and close. The attractive force between 2 spheres is 10 newtons. What would happen to the distance to make the new force 40? So I'm going from 10 newtons to 40 newtons, so I'm getting times 4 for my force. We know if we want a bigger force, we're going to have to decrease, get closer together. So decrease the distance, we cross out A and C. I want 4 times the force. If I do 1/2 the distance, like this, that would be 1/1/4, which would then be times 4. So I would half the distance. Phobos, a moon on the planet Mars, has an orbital radius of this. It has an orbital period of this many seconds. That's t. Determine the mass of Mars. So I'm going to use my t is 2 pi r over v equation. If you're like, where did you get that? I have all the equations over here. So this equation right here. I'm going to rearrange because I'm trying to get velocity from here. So multiply the v over and divide the t over. So v is 2 pi r, which is 9,380,000, over t, which was this. So that gives me a velocity of 2 pi times 9,380. So 2138 for my velocity. Now that's not my answer, because what I want is the mass, but I can use my other equation from this unit, v is square root of gm over r, and I now know my velocity. G is a constant. I still know r. Looking for m. I'm going to rearrange first before plugging in. So first thing we need to do is square everything. So that gives me v squared is gm over over r. I'm going to multiply this r up, and then I'm going to divide the g over like this. So then now we just plug in 9,380 for my r. V squared is 2138 squared over g 6.7 e negative 11. And that gives me 6.4 times 10 to the 23 kilograms for my mass. 6, the net force on the center object. I'll call this A, B, and C. I want the net force on this guy, so let's look. A and B are going to attract each other. And then B and C are also going to attract each other. Now in order to find the net force, I'm going to need to know the force between A and B and the force between B and C. We're talking about the electrostatic force between two charges, so that is this one, K, which is 99, charge 1, charge 2 over the distance squared. So AB, we've got 99, charge 1 is 6, charge 2 is also 6, divided by the distance 0.1 squared. BC is 99 times 6 times 9, divided by a distance of 0.15 squared. And now let's just type in. You'll notice we do not plug in the signs for this equation because that just tells me attract or repel, and we already know that. Alright, so these are my two forces. That's not my end answer. I want the net force. We know that they're going opposite directions, so I'm going to have to subtract the bigger one minus the smaller. AB is the bigger one, so I'm just going to subtract AB minus BC, and that gives me my net force is 1.08 times 10 to the 13th, and because the bigger force was AB, that's to the left, so my net force will be going to the left. So that's my answer. In which of the following situations will the electrical force decrease? So electrical force is K Q1 Q2 over R squared. So if I want a smaller force, you want less charges, and you want to divide by bigger numbers, you want a bigger radius. So charges decrease and the distance increases, so C. And if you wanted a bigger force, you would want more charge and less distance. Two charges are 6 meters apart, and they repel with this force. The distance is decreased to 3 meters. What's the new force? So this is my old force. So this is a what would happen question. Instead of telling me what the distance is doing, it tells me 6 meters to 3 meters. So if I'm going from 6 to 3, that is 1/2 the distance. And then now we just plug in half the distance. And that's going to give me 1 over 1/4, which is times 4. Now, getting 4 times bigger is my answer. I have to take this old force to e negative 5, multiply by 4, and that gives me 8 e negative 5, which is my answer. A person rubs a neutral comb through their hair, and the comb becomes negatively charged. So if something was neutral and now is negative, that means it gained electrons. Which of the following is the best explanation? So the comb gains electrons. The hair can't also gain it, so let's make a note to the side. If the comb is gaining electrons, that means the hair is losing electrons. We can cross off anything about gaining or losing protons because that's not the case. And we just said that the comb becomes negative because it gains, so the hair must lose. So C, hair is losing. Positive charge of this much exerts a force of this much. This is my force, and it's this far away. That's my distance. This is my first charge, Q1, and I'm looking for Q2. So this is not what would happen because nothing's changing. This is a straight plug in. F is KQQ over R squared. So 5.1 equals 9E9. First charge is 8.4 E negative 4. Q2, I don't know, over R squared, so over 14 squared. So, not 14, 4 squared, which is 16. Let's put the top part over in our calculator. So I got the top is 756 with some zeros, Q over 16, because 4 squared is just 16. You can multiply the 16 up. That gives me 81.6. And then now we just divide this 75, whatever, how many thousands that is. And that gives me a charge of 1.08 e negative 5. I guess 1.07. So we can cross off A and C. And now to figure out if it's positive or negative, we just have to, that we would not get that from plugging in. We have to look. It said an attractive force. The other one is positive. We know opposites attract, so if a positive is attracting another one, then the other one must be negative, so B. Again, we would not have gotten that by plugging in signs. We have to read whether it's attractive or repulsive. A neutral electroscope when a positively charged strip is brought near, so we know If you bring a positive, the electrons are going to come up, so we can cross off these because it should be negative at the top. But it says it's a neutral electroscope. Well, the electroscope is this part. That's not neutral, that's negative. Here, this is neutral because it has negative on top, positive, that would balance out. A rod with a charge of +4 and a sphere of +6. So this is my rod, this is my sphere. Touch one another, mark all that are correct. Well, that's a total of 10, so when they touch, that'll be 5 and 5 each. So they both started positive and they're still positive, but there was some transfer. So this one became more positive, so that means, and this one became less positive, so that means this one gained electrons and this one lost electrons. Because at first this was +6, but now it must have gotten an electron to balance out to only be +5 now. So if this one loses and this one gains, it's going from the rod to the sphere. So the sphere gains electrons, agreed. They go from the sphere to the rod, no, they leave the rod and go to the sphere, so B is not true. The rod loses, yes, we said lost, so that's true. Protons, no. The sphere becomes negative, no. So it's just A and C. All the resistors in this diagram are 2 ohms. Which arrangement would have the highest total current? So let's think the most current comes from the least resistance. So I want to know which one has the least R total. So let's start with this one, these 3 in parallel. So I would do 1/2 plus 1/2 plus 1/2. Don't forget to do 1 over that. So that gives 0.67 for this guy. And then this one is still right here, so you'd have to add those. So this one has an R total of 2.67. Here I would do these 2 in parallel, 1/2 plus 1/2, 1 over that. That just gives me 1. This one would also be the same. So then those 2 together gives me an R total of 2. Here, this would be 2, 2, 2. So this really is just a 6. And then 6 and the 2 in parallel. That gives me an R total of 1.5. And then here, all 4 in parallel. Gives me an R total of 0.5. So the highest total current comes with the least resistance, while this one has the least resistance. This one would have the least current because it has the most resistance. R total for this circuit. So we're going to do these 2 in parallel. That's 1/1. Oops. 1 plus 1/1. 1 over that. So that gives me right here is 0.5. And then 0.5 plus the 2. So that gives me an R total of 2.5, which is E. Total current of the circuit, well, this is just 12 volts right here. So then V equals IR. Total voltage is 12. Total current is what we're looking for. R total we just said was 2.5. So we divide over and we get 4.8. And the voltage used by this guy, well, the current coming out of the battery we said was 4.8 amps. When it comes here, it's going to split, but then it's going to come back together. So here it's going to have the 4.8 amps right here. V equals IR, so the current is 4.8 times just this resistance, because I want just this voltage. So that gives me a voltage drop of 9.6 volts. The current through the 16 ohm, well, this is my V total. This is like my R1, this is like my R2. I want to use V equals IR because I only have total current, or sorry, total voltage. Then I'm going to look for total current. It doesn't matter what current because current is all the same for a series. So then if I'm using this equation, I have to use R total. For a series, R total you just add. So here, R total is 24 ohms. So then we just plug in. 18 I total 24, divide the 24 over, like this. That gives me 0.75. Voltage drop across the 8 ohm, well, 0.75 amps for each of these, because current is the same throughout. So then if I'm using V equals IR, I'm looking for V1, so use I1, R1. Well, all I's are 0.75 in this circuit, and R1 is 8, so that gives you 6. The resistance of the missing resistor, so 2 ways you can do this. What I do is I say, okay, this is V total. This one is I, doesn't matter which I you call it. It can be I1, I2, or I total, because I is all the same, doesn't matter. So I'm going to use V equals IR. If I have this voltage right here, then when I plug in the 120 and 0.5, when I divide over, that's going to give me R total is 240. Now careful, because 240 isn't what you asked for. I asked for the missing resistance, but if I know the total resistance is 240 and this one's 50, well, I can just subtract and get 190 here, which is my answer D. The other way you can do it is you can multiply and say, okay, 0.5 times 50 ohms, that's a voltage drop of 25. And then you can say, well, my total voltage is 120. If that one drops 25, then this one has to have a drop of 95 volts, and then divide it by 0.5, the current, and that gives me 190. It doesn't matter. Either way works. Which of the following would be the best way to decrease the current running through a circuit? So I'm going to use my V equals IR. I'm going to divide the R over. So you can say that current is V over R. So if you want the least current, you want a small voltage and you want a big resistance. If you want a big current, then you want big numbers on top dividing by small, but I want a small current, so I want small numbers on top and divide by big numbers. So decrease the voltage and increase the resistance, which is A. You also can think about it conceptually, like the voltage is like your battery. The less battery, the less current that's going through it. And then the more resistance, well, resist means go against, so if I have more resistance, then less can get through. The reading on ammeter A, so first of all, this is a parallel circuit. Voltage is the same, so this is my V total, and then this one also has 12 volts, and this one also has 12 volts. When I want this current right here, well, I can just do V equals IR. I'm looking for I1, so I use V1, which is 12, and R1, which is 20. So then you just divide over, and that's going to get you 0.6. So we've got 0.6 amps right here. The voltage are drop across the 30 ohm. Well, it's parallel, so it's just 12. You don't need to solve for that. The circuit to the right shows 4 resistors in series. What is the current in the first resistor? Well, this is my V total. I have my individual R's. I'm going to use V equals IR. This is series, so I is the same, not voltage. So if I am plugging in V total, then I have to use R total, and that's going to give me I total. Our total, we just add up 4 plus 6 plus 6 plus, I think that's a 6. So our total is 22 ohms. V total we said was 12. Divide over, and that's going to give me 0.54. Yep. Oh well. 0.54, we'll just round that up to 0.5, or round that down, I guess, to 0.5. The total current in the circuit is 2 amps, so what's the voltage of the battery? So I have total current is 2 amps. That means when it comes here, these are equal resistances, so each is going to get 1 amp and 1 amp. So then you can say, well, this one has a voltage drop of 6 volts, so then the battery has a voltage drop of 6 volts because it's parallel. You also can say I total and do 1 over 6 plus 1 over 6 is 1 over R total. That would give me an R total of 3. So then if you use V equals IR, total voltage, total current, and total resistance, 2 times 3, that also gives you 6 volts. It doesn't matter. Either way works. We will pause and do the second half of the video later.